vehicles currently in use employ conventional radio frequency or RF technology for control and operation of the vehicle. However, there are areas of the world where RF operation is not feasible because of government restrictions. Some of these areas include Japan, Korea, and parts of Europe. In addition, RF operation of a vehicle depends on line of sight to work, and there are many instances where line of sight between the operator and the vehicle is not possible. Examples are some urban areas, parking garages, mines, and mountainous terrain. To address these issues, ARA has designed an innovative solution, the Fiber-Optic Communication and Control System, or FCCS, for remote-controlled vehicles. This system automatically dispenses and retrieves fiber-optic cable from a spool for tethered remote operation of a vehicle and gives the operator the ability to communicate in a radio-restricted, jammed, or silent area. No operator control of the distribution or retrieval is required. The operator only needs to follow the cable to return to the starting position. The FCCS can be installed in 30 minutes or less by 2 operators and is mounted to the rear of a vehicle using a bolt-on mounting bracket. All cables have quick connects. When using a fiber optic cable for communication and operation, the potential for cable damage can be a concern. The cable can be broken or damaged if it is run over by the vehicle or if the cable is subjected to too much tension. The risk of damaging the cable is especially acute when using fiber optic cable since it is relatively fragile. To reduce the risk of cable damage, the FCCS automatically controls the speed and direction of the spool motor to maintain the cable in its predetermined position. The predetermined position of the cable is the position where the natural arc formed between the cable release point and the ground where the cable experiences no tension other than the weight of the cable itself. This position is also known as the home position. The FCCS uses a flex sensor to reliably provide the control system with the position of the cable relative to the home position. As the cable moves away from the home position, the control system increases or decreases the rate at which the cable is being dispensed accordingly. The further away from the home position, the faster the cable is dispensed or retrieved. Using the flex sensor, the control system quickly determines the correct rate of cable dispensing or retrieval to match the speed of the vehicle. The FCCS is operable at speeds of up to 8 miles per hour. The FCCS includes a traverse mechanism that synchronizes the release point of the cable so that the cable is dispensed, retrieved, and stored evenly. The traverse mechanism is coupled to the spool so that when the spool motor rotates the spool, the traverse mechanism travels the longitudinal axis of the spool, keeping pace with the rotations of the spool. Constant tension must be kept on the cable during retrieval to keep the cable from getting tangled on the spool. To accomplish this, the FCCS uses a pinch wheel and a drive wheel that are coupled to a motor. Cable is fed and compressed between the pinch wheel and the drive wheel, which are operated at a constant torque. The FCCS monitors the direction of travel of both the drive wheel motor and the spool motor and maintains synchronous operation of both motors, ensuring smooth operation. The standard FCCS configuration can carry up to 2 miles of fiber optic cable. It is equipped with a sensor that warns the operator when the amount of cable on the spool is low so that the operator does not break the cable. All enclosures on the FCCS are environmentally sealed, and the system is operable in temperatures ranging from -20 to 120 degrees Fahrenheit. The FCCS will run on 120 volts AC power or on 12 volts DC power. The system operates independently of the platform control, relying solely on the sensor mechanism to indicate the position of the cable. The system mode is set from an operator control station via JAWS-compliant commands. The FCCS is available with ARA's Universal Operator Control Station, which can be used to control a variety of vehicles and can be used with RF and fiber optic control. The FCCS has multiple communication channels allowing for bidirectional transmission of video, data, and audio. There is one Ethernet channel, 2 serial data channels, RS-232 or RS-422, one audio channel, and two video channels. The Ethernet channel is used for communication to the system but can be interconnected with other Ethernet already on the vehicle. An integrated camera can be connected to one of the video channels for visual feedback of the cable dispensing retrieving mechanism. The FCCS comes with a small camera mounted below the cable release point for constant video monitoring of operation. Forward retrieve is a special operational mode designed for surface clearing such as runways, minefields, and UXO identification and disposal. In normal operation, as the vehicle is driven forward, cable is dispensed. When the vehicle is driven backward, cable is retrieved. In forward retrieve mode, the vehicle is driven straight out away from the operator dispensing cable. When the vehicle has reached the desired destination, the vehicle is turned around and positioned parallel to the already dispensed fiber. At this point, the forward retrieve mode is activated. If the sensing mechanism indicates that the fiber is too far behind the vehicle, it will retrieve the cable until it is at the home position. Forward retrieve mode allows the operator to drive the vehicle forward and retrieve cable at the same time. In forward retrieve mode, cable is never dispensed. The fiber-optic communication and control system is scalable and can be customized to fit many different vehicle types and sizes, as well as cables of various lengths and diameters. The FCCS is an ideal tool in a variety of situations. For example, setting up a temporary communication site where fiber-optic cable is going to be webbed to many locations and picked up later, search and rescue operations, surveillance, underwater operations, hazardous area operations, and areas under RF restriction.